Welcome everyone, and thank you for joining us today for this webinar titled Introducing MLflow, Infrastructure for the Complete Machine Learning Lifecycle. My name is Cyril Simeon and I will be your moderator for today. I'm very excited to have Matej today as our speaker. Matej Zaharia is a co-founder and chief technologist of Databricks, assistant professor of computer science at Stanford University as well. And Matej is really well known for starting and as one of the original creators of the Apache Spark project, and is also the creator of MLflow. Before we get started with today's presentation, I just want to go over some of logistic items to ensure that you have the best experience. So first of all, your audio connections will be muted for the entire webinar, so we can't hear you. However, feel free to use the panel from BrightTalk to give us feedback or ask us questions as we go through the presentation. The recording will be available and posted via BrightTalk and Databricks.com as soon as it's over, and the slides will be available and sent over to you over email at the end of the presentation as well. The questions will be unanswered throughout the webinar, but we will keep them for the end, and we'll make sure that we allocate enough time at the end of the webinar to answer as many questions as we can. And if we run out of time, we'll just follow up over with a blog, a wrap-up blog, and we'll make sure that we can address all of your questions. So with that, I'll pass the mic over to Matej, who will kick things off. Thank you.
All right, thanks, Cyril. So this is kind of the outline for the webinar today. I'm going to start by talking about machine learning development challenges, and then how the MLflow open source project tackles these. I'll have a short demo of MLflow, and I'll also talk a little bit about how to get started with the open source project and begin running code and so on. So that's basically the plan. So I think everyone who's tried to do machine learning development knows that it's pretty complex. And I want to start by talking about the ways in which it's complex to understand, why some infrastructure around it can help. So this here is a picture of sort of the typical machine learning life cycle. And you can already see that it has a bunch of different stages. So typically you'll want to do data preparation. Getting high quality data is very important for machine learning. So you need to turn your raw data into some kind of cleaned up prepared data. Then you'll need to do model training. Then you'll need to actually deploy the model to a production application. And finally, if the model is actually doing something important, you probably want to monitor it, and that generates even more raw data that you then want to analyze and maybe feed back into it. So there are a few things that make this difficult. The first thing is that there are a lot of different software tools involved. So for example, just if you look at the raw data, it can be stored in many different storage systems and locations with different ways of accessing them. And it's usually important to bring in as many sources of data as you can that are relevant to a problem to build a really good model. Then for data preparation, a lot of different algorithms and tools you can use for data preparation, and same thing for training. So in both data preparation and training specifically, one of the key things about machine learning is you usually want to try a wide variety of algorithms to see which one works better on your problem. So you really want to be able to try all the available techniques. There isn't just one that's always the best one. And then, of course, you have to deploy your model. There are a variety of different deployment tools which require their own work. So this is kind of the first challenge, lots of different types of tools involved. Beyond that, some of these tools, so the second challenge is some of these tools also come with tuning parameters, so hyperparameter tuning, if you've seen that as part of machine learning. So not only do you have to think about, which ones you want to try, ideally be in a position to try many of them, but also you get sort of this extra dimension to the problem, which is which parameters did I use at each step. And if you don't spend time exploring the parameters, or if you forget which ones you use or whatever, that can be a significant problem. Then on top of that, all of these things have the challenge of scale, so they need to operate at large scale to make use of all the available data in many cases. And there's also a challenge of just exchanging models and code and sometimes even data between these tools. There often isn't a very standard way to do that. So for example, in many organizations, the team that does deployment has to rewrite some of the code that went into training, and that's a chance where, maybe there'll be a subtle difference or a mistake, and then the model will behave poorly once deployed. And then finally, in any large organization, you also worry about governance. So how do you keep track of what's being used? Can you audit it? Can you go and fix problems if anything goes wrong, and so on? So these are some of the challenges. So just as an example, I'll include some quotes from some of our users at Databricks who work with machine learning every day. So this one here is from the chief scientist at an ad tech firm, and he says, I build hundreds of models per day to increase revenue using any machine learning library, MLlib, PyTorch, R, etc. And there's no easy way to see what data went into a model that I built a week ago, tune it, and rebuild it. So this is a very typical kind of problem. So the goal at this company is to lift revenue. It's very easy to measure. You can measure your click-through rate and dollars per click and things like that. Even a small increase, like say 1% increase in click-through rate, can lead to a lot of additional revenue. And of course, this data science team is going to use any available tool to do it. They're not going to say, well, we're only using deep learning, or we're only using random forest or whatever. So they spend all day experimenting with these tools. And now they have the challenge of, okay, how do you actually use all these tools in production? And then how do you reproduce and just keep track of what happens so that you can reliably make progress? The same thing happens, at a kind of a different level in larger companies. So this is a quote from a large consumer electronics firm, and they say, our company has 100 teams using machine learning worldwide, and we can't share work across them. Whenever a new team tries to run some code that some other team built, it often doesn't even give the same results, because so much depends on the environment you ran it in, the parameters, the exact data, the data preparation steps, etc. So again, you can imagine in a large company, this will really slow down progress with machine learning. You spend a lot of time just trying to rebuild and figure out what someone else did, as opposed to building up on it and using your own expertise to do something different. So what can we do about this? So one trend that started in a lot of companies of all sizes is building machine learning platforms that try to standardize the machine learning lifecycle. So this happens in companies of all sizes, but some of the sort of best known ones that people have posted about are from large web companies. So Facebook has a platform called FB Learner, Uber has Michelangelo, Google has TFX. These are internal platforms that some teams, or sometimes many teams, use to develop machine learning. And the idea of these platforms is that they standardize the machine learning lifecycle. So if you work within this platform, which is usually a limited set of APIs and algorithms, then it can handle data preparation for you. It can handle training. It knows how to deploy anything that you built using the training tools in there. And you just get these things automatically. And you can focus on, kind of your business problem, and then the engineers who build the platform essentially handle these things for you. So that's kind of the benefit. It's very powerful for quickly building machine learning products and getting reliable results out of them. But on the downside, there are definitely a few limitations to these platforms. So all the users, you talk with of these kind of platforms, they say, I wish it had more algorithms or frameworks supported. They're usually limited to a few, where the engineering team behind the platform builds the complete support. And then the other problem is that they're tied to each company's infrastructure. So it's very hard to, to share work or to collaborate across companies. Everyone is sort of redoing the same the same kind of engineering to build these systems. And of course, it's a lot of work for everyone involved. So at Databricks, we saw this trend and we started thinking about it, and we asked whether we can provide the same benefits but in an open manner, where you can have a platform that's open source, but that's also open in that other people can build tools internally or externally that work with it, and they can sort of bring their own tools to run inside it and get this ecosystem effect. So that's what we're doing in MLflow, this open source project that we introduced in June at the Spark and AI Summit conference. So MLflow is an open machine learning platform. It's open in two senses. It's open source, but it's also open in that it's designed so you can plug in libraries, algorithms, deployment tools, visualization tools, and so on very easily, and customize it to the things you need in your organization. So it works with any machine learning library and language. It's designed to run the same way anywhere. So for instance, you can run jobs on any public cloud or on-premise. And it's also designed to be useful whether you're a single data scientist working alone on a project or a large organization. So we try to make sure it's useful even for that individual data scientist who, usually doesn't want anything to get in their way. They just want to quickly iterate. And we hope it accelerates that as well. So I'll talk a little bit about the design philosophy, and then I'll go into more detail of what it provides. So there's kind of two pieces to the design philosophy that make it different from previous platforms. The first is that it's an API first or open platform, which means the whole platform is basically built around REST APIs and command line interfaces, and you can easily use it with any machine learning library, programming language, or application that you already have. So it's not limited to a small set of libraries that we're going to support. And there's a lot of different ways that this happens. Just one example is for deployment. In MLflow, you can build custom deployment options for whatever library and algorithm you have. But another thing you can do is you can just provide basically a Lambda function that deploys your model. So as long as you can package up your model as a Python function, MLflow knows how to deploy it in a wide range of different deployment environments. So for instance, it can put it in a Docker container for serving on Kubernetes. It can put it into cloud-hosted services like Azure ML. It can turn it into a user-defined function in Apache Spark, so you can use batch scoring and so on. And so that's an example where you can bring your own algorithm and still benefit from the platform. And the second aspect that was really important for us was to have a modular design. So MLflow is built of several different components, and we designed it so you can use each of them individually. So even if you have an existing machine learning workflow and, some parts of it you really like and you want to keep them the same way, maybe you can benefit from some of the other pieces of MLflow. And again, this is because many companies, many users already have their own process. And so we built it into these components. You can use them together. You can also use them on their own, and you can bring your own tools to use around with it. And then the final thing is, we made it open source. So why open source? So first of all, everyone is solving a similar problem, so we can pull together resources to build a really great platform for this. And then the other thing is that there are a lot of benefits for the machine learning development process as a whole in having a common API. So, for example, a lot of people publish open source machine learning algorithms and projects. Definitely, in my work as a researcher, my students end up publishing a lot of different tools on GitHub, and then they also try to run code built by other machine learning researchers. And it's a huge pain to get these things to run again in a different environment. It takes, it can take like up to a day to set up the environment and just run something that another researcher published just for the purpose of getting people to use it. So with a tool like MLflow, these can have a common packaging format where you can just run one command in order to execute these things, and it's good for the people people who publish them, and it's also good for the people who consume them. Same thing happens with machine learning tool developers. So, for example, if you built a new machine learning library, you don't have to build the integrations with many serving tools because you can get those from MLflow. So this is sort of the long-term goal to enable this both inside and across organizations. Okay, so next I'll jump into the actual components of MLflow, and this is where I'll show them through a bit of a demo as well. So the current release of MLflow has 3 components, and we intend to add a few other pieces over time, but these ones together are enough to get a pretty powerful basic workflow going. So there's MLflow tracking. This is a component to record and query experiments. So as you run your machine learning code, whether it's a single step or even multiple steps, we can remember which code you used, which version of the code, which data, which configuration parameters, and also which results. And this makes it very easy to compare results as well, whether you're a single person working on a project, looking at your historical data, or you're a team of people. The second component is MLflow projects. So this is a packaging format for your code that allows it to run reproducibly on any platform. So one thing you can do with this is, package up your code, and then you yourself can run it a few weeks later when you forgot, what you did the first time you set it up, which, does happen. But another thing you can do is, for example, package up your code and submit many runs to the public cloud, and then run them on there and do a lot of experiments in parallel. And then you can make sure that they're running in the same way that they ran on your laptop where you developed the code. So that's the projects component. And then the final bit is MLflow models. So this is our model packaging format and also, model deployment tools. And so we have this pretty general format, as I talked about, where whatever library you're using, you can package it in a simple way and then deploy it to many different tools. And this creates this bridge between the people or the teams that handle deployment and the people who build models, where someone can deploy your model without knowing what you had to do to build it, and also you can take the same model and use it, say, in Spark and in a batch application, and also on a mobile phone in a mobile application, and you don't need to change your model. So that's the models part. Okay. So to show all these pieces together, I'm actually going to switch to sharing my screens, and I'll show a little demo of using MLflow to solve a machine learning problem. And so in this demo, I'm just going to use a pretty basic machine learning problem, but definitely, kind of an impactful one, which is using this Airbnb data set. We're going to try to predict the price of an Airbnb listing based on its characteristics. So listings have a lot of different attributes, like, number of bathrooms in the apartment, number of bedrooms, how many people, the average rating, and so on. Why would you want to do this as an application? If you're Airbnb, for example, there are a few reasons. So one reason might be when someone posts their apartment on Airbnb, you may want to recommend the price to them and tell them, okay, we think you should charge this much for it, and, help them find a good deal. Another reason is, maybe someone has posted an apartment and just made the price way too low or way too high. You can tell them about it. You can say, similar apartments in your area cost this much and yours is twice as much, so maybe that's why no one is picking it up or whatever. So that's from a machine learning standpoint, this is a regression problem where we're trying to predict this thing, but it's something that the business may want to use. Okay, so I'm gonna share my screen. Let's see. 1 second. All right, so hopefully people can see that. Yep, I see it in there. Okay, and then I'm going to start working with this data out here. So what I've got here, I have a little folder with some code to do this machine learning problem, and I have 2 files in Parquet format with the data. The tests, I split it into testing data and training data, which is just a bunch of listings from this public call of Airbnb. And I'm going to show some code to work with it. This is a really simple Python script that I wrote to do this, that just builds a linear model. And this is sort of, kind of the simplest machine learning model you might want to use for this problem. And I'll show it first without using MLflow. So there's a little bit of code in here, but the main thing this is doing is it's importing this thing called ElasticNet from scikit-learn. ElasticNet is a linear model with regularization, which is just sort of one tweak on the model that can help prevent overfitting. So that's what it is. And like pretty much any machine learning algorithm, this has hyperparameters. It has these tuning parameters, and here there are two of them. There's alpha and L1 ratio, which control the amount of regularization, which again, as I mentioned, can lead to better generalization of the model. So what I do in here is I load these parameters, I load the data, and then I train it. And then the final thing you want to do is evaluate your model. And there are many different metrics you can use to evaluate regression. So in this one, I'm actually using 3 metrics. There's mean absolute error, MAE, there's root mean square error, and then there's R squared, which shows how well the predictions of the model are correlated with, the actual prices of those listings. And again, if you work with machine learning, you'll be using different metrics and looking at them in different situations based on the problem. So, okay, so this is our code. There's like a little bit of code to do these pieces below, but that's basically it. And, how would I use machine learning today without MLflow? Well, I would probably start running this thing. So, let me just run it with the default parameters, which are 0 and 0, and it printed some metrics. So, okay, it's got a certain mean absolute error and so on. And maybe I want to try some of the parameters. Maybe I do 0 and 0.5. And it actually didn't do very differently. This is almost the same behavior. Maybe I do this, and okay, now the metrics are a little different. Let's just focus on one of the metrics, which is this R squared. You can see this one went from 0.24 up here to 0.27. So maybe this improved. And if I spend a lot of time tuning my model, maybe I can make it even better. And I'll spend a lot of time experimenting with just these 2 parameters, not to mention the code or the data. So you can see this quickly becomes pretty unwieldy. If I'm editing all this stuff, I can easily forget what I did, and it's pretty painful to keep track of this. So how would I accelerate this process with MLflow? So the first component of MLflow I'll show is the MLflow tracking component. I created a different copy of this code snippet where I'm using that. So this is pretty much the same code as before, except that I import MLflow, and I also import MLflow.scikit-learn, which I'll use later. And I'll start by showing the tracking bits. So you can see, as before, I'm loading my data, I'm doing this stuff, but I have these logging statements in the code. So in particular, I'm gonna tell MLflow to log my parameters, the alpha and the L1 ratio, and that's gonna record them in here. And then I also have some more logging statement at the bottom. So once I record the metrics about my model, I'm going to log them, and then the final thing I can log is called artifacts. So you can also, apart from logging metrics and parameters, you can actually log arbitrary files from MLflow. So I'm going to log here, just as an example, some text files, some image that I built. Maybe these are things I would plot in my model, and I'm also going to log my scikit-learn model. And this is going to be really useful if I want to serve it later, or just if I want to load it back and see how it performs. So that's kind of the MLflow tracking API. It just lets me log this stuff. I'm just going to clear some stuff a little bit here. Okay, and so now I can run this application that I wrote, and again, I'll just run it with a few parameters. Whatever it's doing here, and like before, it's printing this stuff. But the thing that's different now is that MLflow actually tracks all the runs that I did. And by default, MLflow is actually going to track these on my laptop. And I have a folder here called ML runs. And you can see in this folder, it created these sort of subfolders for every run that it recorded. So that's what it does by default. And what I can do now is I can actually tell MLflow that I want to visualize these. So I can just launch this UI. And if I go in here now, I can actually see this UI with all the runs that I did. Let me just zoom in on that a little bit so that people can easily see it. So you can see these are the 4 runs that I did. These are all the metrics out here. And I can sort them. So for example, I can quickly find which one had the best R-squared, or I can even take some of them and compare them with each other and, maybe get this nice plot where, let's say I'm going to compare the R-squared and the L1 ratio or something like that. And I can quickly start to see how my model is doing. So that's the tracking UI. So that's already pretty nice compared to me just working in a terminal, and I just had to do these little print statements, these sort of log statements in there to do it. So that's MLflow tracking. Just to switch back to this to talk a little bit more about it. You can use MLflow tracking in any environment where you can run code. So you can use it in notebooks, you can use it in local applications, you can use it in jobs on the cloud. And I showed logging stuff locally, but you can also start up a tracking server if you want, and then report stuff to a remote tracking server. And you can get, you can then visualize the results through the UI that I showed or query them through an API. So it's many different ways to access the data and to figure out how to best improve your model. Okay, let's switch back to the screen share. Okay, so now I'm going to go into the second component of MLflow, which is projects. So by tweaking this linear model, I was able to improve my metrics a bit. I was able to get my R-squared up to 0.28, which is good. But it's not actually a very good result for this data set, and I think I can do better. And so one of the things I may want to do is try a different machine learning model. I'm just going to try doing this using random forest. Now, most people, when they're going to do this, they're going to look for some example code that they want to start with. So I'm going to use the XGBoost random forest. I'm just going to search for XGBoost random forest regression, and there are all these posts and stuff. I might copy and paste some of the code, or maybe I can even find I can find some code on GitHub. So, for example, this might be like, well, I guess this is actually an issue, but if I'm lucky, I might find an actual, an example of someone running this. That's maybe this is an example of a GitHub repo that runs random forest. So even if I find an example that's using it, and this is an open source random forest implementation, so there are lots of examples. Once I find it, I'm kind of stuck. I have to look through the code to figure out how to run it, how to feed data into it, and so on. And it's difficult to just run this code and apply it to my problem. So this is where MLflow projects come in. MLflow projects are a way to package up machine learning code into a form that you can easily share with others and let them call it on new data. So in this case, there happens to be this company that already published an example XGBoost regression, snippet using MLflow. And so this is also just a GitHub page with some code in there. It's got some Python code, but it also has this special file called ML project that tells MLflow what it needs in order to run it. So in particular, just to zoom in on this, ML project tells you the dependencies. In this case, it's a Conda environment with Python dependencies. And it also tells you how to invoke the project. So in particular, it says there are a bunch of parameters. Some of them have defaults. And there's a command that helps you actually run this code. And so as a as a user of MLflow, I can go to this thing and I can actually, if you look at the conda.yaml, this is going to have the actual dependencies on libraries that it has. I wanted to show that too. And I can go and I can just kind of take this path to the repo and run it. So what I can do is I can say MLflow run and this example, and then I can just feed it some parameters. So this one took this one took some data files, and it also needs to take which column I'm predicting, which is going to be the price column, and I can just run it. So actually, I misspelled this. I guess it should have been called training data. Sorry about that. So yep. Okay. Yeah. So what this will do is it will download the project from GitHub. And it will actually set up a conda environment for it. In this case, the environment was cached because I ran it before. And it will set up all the right libraries, and then it will run it and feed it in my data. So you can see we ran, in this case, we ran this XGBoost model, and it produced this R squared that was 0.29. So it's already better than what we started with. If I look at it here, you'll actually see that it's actually already the top model in terms of R squared. And because this is packaged in a project, I get a few other benefits. So for example, MLflow records the version in Git of the code. So I can just click this version and actually see the exact code, the code version on GitHub that I ran, which is great for debugging this thing later. And if I want, I can also click through and I can see the command that will run it with exactly the same parameters. So this is telling it the Git version, and it's also telling it all the parameters. So I can really see what all of these were. And that's what it's doing. The other thing I can do is I can use the interface to the project to keep tuning the parameters. So for example, in this case, we did random forest with 200 trees, and it did, it got a certain result. I'm going to try it with 400 trees, and maybe I can also try it with like 500 trees or something, and just see what it means to change this parameter. So I don't even need to understand the code in the project really to change these parameters. I just need to run it. And so again, if we refresh this page, just going to hide this, you can see, adding more trees actually helped a lot when I went up from 200 to 400. And it looks like the best result was actually with 400 trees. So that's, that's how easy it is to use an existing project that someone else wrote. And then the final thing, so that's the MLflow projects thing. And then the final thing I wanted to show is the MLflow model. So remember at the beginning how I said you can log arbitrary files. So for example, in this case, we logged this text file, we logged an image, we also logged a model. One of the special things you can log is a MLflow model, and that's just a folder with a little descriptor file that talks about the model and some additional data. So both my original project and the XGBoost one log models. And if you look at these models, you can see the interesting thing about these models is they define different what are called flavors for how one can load the model. So in particular, this scikit-learn one has a scikit-learn flavor, which allows me to load it back into scikit-learn, and it remembers the version. And it also has this Python function flavor. So any tool that understands how to call a Python function for model serving can actually use this model without even having to know about scikit-learn. And then it's got some data, which is the pickled model. The same is true of these ones I did with the XGBoost code. They also have a model in the same form. So what I can do is I can take this run ID of the run that was most successful for me. Actually, let me go back and take the one with 400 because this one was the best one. And I can then start using it in a variety of different serving tools. So for example, one of the things I can do is I can apply the model to new data. So I can take this run ID, I need to put the path inside it too, and I can put in a file. I happen to have this in.csv file with, with a bunch of locations, basically a bunch of a bunch of apartments, and I can get predictions for it. That's what I did above. Okay, and then I can actually, I can actually compare it. So in this case, I have the actual, in prices. I have the actual prices for it, and you can see, this model is actually doing pretty well. So the price that it predicted for each thing is pretty close to the actual price. So, like for instance, 478 versus 450. Another thing that I can do with these models is launch a server. So instead of passing it some input data, I can just do MLflow pyfunc serve, and I can tell it a port to listen on. And this has actually got to launch a REST server that will serve my model. And if I wanted, I could package this up into a Docker container too and deploy it. And then what I can do in here is scoring. I can actually pass some data to this server. I'm just going to show the script to do it, but this is basically just sending an HTTP request, and I think I need to give it a JSON to pass, and then it will actually score it. So now I have a REST server that can do this. And beyond that, there's a lot of other things you can do with MLflow serving. I'm just going to show some of them in the project documentation. So built-in deployment tools, you can run it locally. You can deploy it to hosted model serving systems such as Azure ML and Amazon SageMaker. You can also load the model into Apache Spark as a user-defined function and then just apply it on data in a batch setting. And in all these cases, as long as your model was saved with one of these general flavors like a Python function, MLflow can serve it. So that's kind of closing the loop and showing the serving part. And so if I switch back, I talked about tracking, I talked about projects, and I talked about serving. Okay. Beyond this, at Databricks, of course, we're working to make sure that MLflow is well integrated into a complete kind of data science environment as well. So I'm just going to briefly show a few of the things that you can do there. So one of the things you can do, I mentioned you can use MLflow in notebooks. So I'm going to show this in a Databricks notebook. You can also do it actually in just in Jupyter notebooks. But what I can do is I can just go and if I have a notebook, I can just import MLflow in it, and I can have these cells that start a run and that actually do some log some results. And I can kick off a bunch of these runs. And then if I go to the hosted version of MLflow in here, I think I called it this one, pricing test. I can actually see all these runs from my notebook. It will link back to the notebook. I can also compare them and see what they did and so on. And this is what it did. The other thing that I can do very easily is if I'm running some code locally, I can submit it to run in the cloud. So remember how I did this MLflow run command to run a project. If this project takes a long time to run, I can just put mode Databricks, and I can pass a cluster.json, and it's going to actually kick it off as a cloud job, and it's going to run that in the cloud, and I can use this to do a bunch of experiments in parallel, and then to go in here and sort of see how it's running. So this tool is something you can use locally, but it's also easy to integrate with remote execution, with notebooks, and with other tools you might use around your machine learning workflow. And the key elements that enable that are the ability to reproducibly run the project in any environment. Okay. So that's kind of a quick demo of MLflow. Hopefully it gives you a sense of what's possible, both in terms of tracking the workflow and in terms of then making use of the models after. So the last bit I wanted to talk about is how to get started. So you can get started by just installing MLflow with pip install. It's very easy to set up, and we've set up a whole bunch of tutorials at mlflow.org that you can try. We also have a mailing list for future updates if you're interested, to learn more about the project and see more of the materials that we're building. There's a lot of exciting stuff happening in the roadmap. It's already it's already got a lot of contributions coming in from different organizations. So something that was already done in the past couple of months is we received these 5 different library integrations that were added to the project. So there's built-in support for saving models and loading models from TensorFlow, Keras, PyTorch, H2O, and MLlib. There are also Java and R language APIs, both in review right now, so hopefully they'll be out in the next release or two. And there's also interesting work and examples on multi-step workflows, hyperparameters, and more powerful data sources and model management APIs. So we're actively building this, and we're also working with a community of contributors to build out this project and make it a great tool for whatever language and library people are using. Okay. So yeah, finally to conclude, hopefully I've shown that workflow tools can greatly simplify the machine learning lifecycle, and these tools can improve usability for both the data scientists working alone and engineers who have to use the model or have to run it again in the future and compare the results and so on. And it's sort of the same thing that software development tools do to simplify software development. No one would imagine developing a production software without, say, a testing system and a continuous build and version control and so on. And these things really make teams more productive. So we're hoping to do the same thing for machine learning with all the machine learning specific details like metrics and parameters and data sets that you have to worry about there. I invite you to learn more about it online. And then the final thing I wanted to mention before I go into questions is we also have this Spark AI Summit Europe conference coming up in about 5 weeks. If you would like to go to London, this is a great place to learn more about MLflow, as well as Apache Spark and different machine learning and data science tools in general. And I've included a special discount code here that you can use to access this, which is MATEI25. So you can use this code, in the next few days to sign up. So that's it. That's what I wanted to show. Happy to take some questions now if Cyril, if you'll let me know the questions.
Awesome, thank you, Matej. This is awesome. So we do have questions coming in the questions from audience panel. So let's see. One of the questions that we had was about the roadmap. So since MLflow is in alpha version, what is the timeline until the first stable version? What's your recommendation?
Okay. Yeah, that's a great question. Yeah. So we care a lot about API stability and making this project something that you can build on and then forget, and then it runs the same way a few years later. So we're trying to get to the 1.0 stable version as quickly as possible. Since it's still pretty new, I would expect that to happen basically around the middle of next year, maybe like first quarter or second quarter of 2019. So we want to make sure that we have enough feedback and we can evolve the project based on the initial feedback. But we care a lot about having a stable API and one where we can grow without creating surprises for the current users of it. Yeah.
Awesome. Another question we have is about the run in the cloud scenario and function. So the question is essentially how configurable is it? And the scenario would be, what if you want to run a job against a CPU strong VM and then later against a GPU strong VM?
Yeah, that's a good question. Yeah, you can do both of those. So the one I showed is running is submitting the job to Databricks. You can and there you can specify a cluster type. You can use GPUs. And CPUs. You can specify the instance types. You can also make it a distributed cluster. I didn't show that, but you can actually submit a distributed Spark or even like distributed TensorFlow job to run on your cluster there. And the other thing that you can can do is if you have another compute environment, you can always, somehow go in there and run it and just point it to the tracking server and send in the results. So you can collect the results from anywhere.
Okay, thank you. Let's see. So we also have some questions about, since we were talking about tracking, so tracking metrics are currently storing on S3. Is there any future plans to store them on database?
Yeah, that's a good question. Yeah, we would like to include, so right now everything is stored in files or in a cloud storage system like S3, and we actually want to include a database storage backend, which will let you plug in kind of any database that the Python sort of SQL Alchemy API can talk to. So this is a pluggable interface. We just haven't gotten to it yet. Yeah.
Okay, thank you. So we have some questions about and that's a question that was asked before the demo and before getting deeper into the presentation, but I thought it'd be good to ask just to make sure that we're all on the same page. So how is MLflow different than H2O AutoML, and is it a competing product, or does it work with H2O?
Yeah, so MLflow isn't really an AutoML project. It's about managing the machine learning lifecycle. So keeping track of experiments, keeping track of models as well, and passing them around between teams in an organization, or even for a single user working with them. So you can still use it though to do a lot of AutoML type things. So for example, on GitHub, we have this example of doing hyperparameter tuning, where you package up the different algorithms you want to try as MLflow projects, and then we can automatically run different versions of them in parallel and compare the results. So you can do a lot of the things that AutoML does, but our goal is not to it's not to kind of give you a model without any input. It's to actually help you as a machine learning developer be very efficient in in understanding your model and understanding your problem. And I think I talked about this before. You can definitely use all the H2O algorithms in MLflow, and you can even save the models and load them into all the serving tools.
Yeah, that's perfect. Thank you. And you also answered another questions we had about supporting auto-parameter tuning, so that's great.
Yep. There's an example of that on GitHub, yeah. Mm-hmm.
Yeah, that's perfect. Thank you. There's also a question about whether we have MLflow in Azure.
Yeah, good question. Yeah, so MLflow on Databricks is currently in private preview, which means we're enabling it for organizations who sign up, but it's not available to everyone yet. The open source MLflow, though, you can use it with Azure. It works with Azure Storage, and I believe we even have a few docs on how to use it, both with and without Databricks, like how to import it and set it up on a server there. So there's nothing tied to it. For the private preview, where if people are using Databricks and want access to it, I think the sign up form on the website is a good place to leave a note, and we're trying to expand that as quickly as we can to add more people. Yeah. Yes, correct.
So there is a specific question on that too. I want to make sure we can address it. If I run MLflow on Azure Databricks, where are the metrics parameters recorded? How can I run the GUI there? So that would be using the open source version today. Mm-hmm.
Yeah, you can use the open source version. You can stand up a server with it, and then the metrics and parameters recorded are whatever you choose to record. And actually, some of these aren't released yet, but in sort of the next release of MLflow, it will also know if you're running it in Databricks, like say in a notebook or in a job, it will actually have a link back to that as well. So when you run the MLflow library inside Databricks, it knows that it's in there and it records that metadata. Same way that I showed, when you run from GitHub, it has a link to GitHub. The same thing will work with execution from Databricks. So I showed a little bit of that when I had my notebook, but that's going to be in the next the next open source version that we publish. Yeah,
perfect. Thank you, Matej. A question about the modularity of MLflow. So do you have to use MLflow modules together, or can we use only tracking module?
Yeah, you can use just one at a time. You definitely don't have to use them together. So if you look at the first example I showed with the linear thing, I was just using tracking. I was just logging some stuff, and I guess at the end I logged the model as well. So I was using that, but I wasn't using projects. So we've seen a lot of people who are interested in just one of the things to start with. Yeah.
Mm-hmm. Okay. Thank you. Does the GitHub projects need to have the MLflow section to directly use in MLflow projects?
You mean the ML project file? Does it need to have that? I think so. What we'd like to get to is there should be some standard packaging formats for projects where if you just have, say, a conda.yaml, we know how to run it. And actually, we can already do, you don't have to declare all the parameters and entry points. You can just say, run main.py, which is a Python file in there, and it will know how to do that. So we'd like to make it so you don't have to write an ML project file. But if you want more control over the project, that is the way to do it. Like, for example, I don't know if people saw this. When I tried running the XGBoost one and I mistyped one of the parameter names, it actually told me this thing requires a parameter called, training data, and you didn't give that. So it kind of depends on the level, the ease of use you want for the users of the project. Yeah.
Okay, awesome. So we'll take maybe a couple more questions and then wrap up. And if we haven't had a chance to answer all of the questions, don't worry, we'll follow up via the blog, and you can continue to add your questions in the Bright Talk panel, and we'll make sure to address those. So Matej, if I'm running grid search function in Databricks Notebook, can that be tracked directly into MLflow?
Yeah, it should be. Yeah. You can even run, in the same notebook, you can do multiple experiments, and it will record all of them, like in different cells, or you can have a loop or something, and it will just log all of them. Yeah.
And is exporting Databricks Notebook to Azure ML Web Service available as part of MLflow open source today?
Exporting a model to Azure ML is open. We're not exporting a notebook. We're just exporting the model that you built, so that function, and that is supported today. Yeah, that's part of the open source project. Yeah. Okay.
So last question for you, Matej, and then we know you have to go. Has there been any thought to integrating something like transmogrifies for automated feature engineering as part of MLflow or similar third parties?
Yeah, that's a great question. Yeah, that ties into the AutoML question also. So yeah, we definitely want to let you to integrate with these types of libraries too. And for example, one thing we could do is, as transmogrify runs a bunch of experiments, we could log the information for each one and let you visualize that, and try to figure out if there's a pattern or like some way you want to reconfigure it to do better. Same thing with packaging up the model. And then the other thing I'll mention, as I did there, is like part of the goal of these projects and the way you can package them is to kind of enable you to build your own AutoML tools. So if you have, for example, two different projects that do regression or that do classification or whatever, some task, as long as they have the same interface in terms of like some parameters like the input data and output data, users can just swap one of them in and out. And so you could imagine building a tool where for your data set and your organization, people can try different featureizers, different classifiers and so on, and combine them together. And so you can have sort of these project builders and then project consumers that are just running them. Yeah.
Awesome, Matej. Well, thank you very much for taking the time to join this webinar, you and all of the attendees. I think we're gonna wrap up the webinar for today, and we'll make sure that we'll publish answers to any questions we haven't had the time to address. This was a great session. Thank you for joining.
All right. Thanks everyone for listening. Yeah.
Thank you.